Hey, welcome back, Sec Plus preppers and CISSP wannabes. I'm Colin Weaver, IT Dojo. This is part 2 of a video that I started regarding a question that somebody had asked me about the generations of firewalls and getting into a more detailed explanation of how the different firewalls were and how they were laid out and what they did and why they were different, etc. The first video went in and covered basically just packet filtering routers and showed an example of how you can circumvent those and why we don't want to use those for protecting ourselves from the the heebie-jeebies that are out on the internet. But we certainly do use them for a variety of different reasons on our internal networks, as well as access control lists in general for a variety of other circumstances like classifying traffic and things like that. So in this video, what I want to do is I want to go in and continue the discussion and talk about stateful firewalls, circuit level gateways, as well as application level gateways or application level firewalls, and what makes each of those what they are, and kind of what the considerations are and the important facts are that are about each one. All right, from the first video, we got that the generations of firewalls are: first generation firewall is packet filtering routers, just packet filters. Second generation of firewall is stateful firewalls, and the third generation of firewall is application level gateways. That's just sort of a chronology that sort of illustrates the history of firewall evolution. Do not try and always jam this stuff into a specific implementation at your office. Certainly things like packet filtering routers exist. Those are very real things. Stateful firewalls exist, but things start to get a little bit muddy when you start talking about circuit level firewalls and application level firewalls, because the vendors do different stuff. Some vendors' implementations of these concepts may have different features. And so as you're sitting there trying to correlate these concepts back into things that you might be doing at your office, I don't want to say they're always going to fit. And I don't want you to hate on me in the comments because you're going in and saying, oh, well, my office, my vendor, my Palo Alto does this, or my Cisco ASA does this. I know. They do different stuff or can do different stuff, and how you choose to implement it can be varied as well. So don't take these as products that you're going to buy. Take these as concepts that would be implemented or be enforced. All right. So as a very brief review, a packet filtering router, if you recall, was a simple device that had an ordered set of rules called an access control list that would look at traffic typically based upon its IP address, source and or destination, and the protocol that it was using, most commonly TCP or UDP. And then there are others like ICMP and GRE and AH and ESP and protocols like that. But these protocols can be examined by the packet filtering firewall, the packet filtering router, and yes or no decisions can be made, permits or denies. And the big limitation of them is that they are static, in that they only look at the packet from a header perspective. They don't actually look at anything that's payload related to make a decision about it from security. And each packet is treated as an independent entity. There is no concept of state, which is where we're going right now, to go in and look at what does this packet have to do with the whole totality of the connection. Packet filtering routers don't do that. Stateful firewalls do. Stateful firewalls are packet filtering routers with extra features. Okay? The same basic notion is there. They still go in and look at, or can look at, source and destination IP address. They can look at whether it's TCP or UDP and which ports the traffic is coming from and which ports the traffic is going to. They can also look at other values like whether the send bit is set or the send and ACK bit are both set, etc., to go in and keep track of that. And here's where the really big difference comes into play. In a packet filtering router, the router doesn't keep track of any of that stuff. In a stateful firewall, it does. It actually maintains a table that we call a state table of the connection-related information. And what this means is that when you create a rule that's going to allow some traffic to go out of your network, the router will examine where it's coming from an IP address perspective and probably from a port and protocol perspective. And it will also go in and examine where it's going to, again, from an IP address perspective and from a port protocol perspective, and write it down. stores it in a table. And it will create, based upon that information, a dynamic reciprocal firewall entry on the inbound interface coming from the untrusted network to allow that specific return traffic to come back in. The benefit of this is that it means a couple things. One, stuff is only allowed in if it's first allowed out. And that's probably one of the most central tenets of stateful firewalling, is that nothing is allowed in unless you create a rule that first allows it to go out. And once you do that, the stateful nature of the firewall creates the dynamic temporary entries that allow the return traffic to come back. Okay? That's the single biggest feature of how these guys do what they do. It also makes them significantly more difficult to circumvent. Because if you go watch the first video that I made talking about packet filtering firewalls, you saw how relatively easy it was for me to circumvent the static rules that were created. Well, now what you're going to have, if I jump backwards a little bit here, if we look at this particular network, over here on the left, if this is my internal network, my trusted network, and I create a rule that allows traffic to go out through this firewall out to the internet, the firewall is going to, because it's now a stateful firewall, is going to dynamically create a rule coming inbound on gig 10 that's going to allow that specific return traffic to come back. Any unsolicited inbound connection is going to be denied. Even if that unsolicited inbound connection were to come, say, from the web server. If the web server didn't start the conversation, which the stateful firewall can keep track of because of the state table, it's going to get dropped. So the only way that the web server is ever going to get traffic to be allowed to come back into this internal network is if you had created a rule that first allowed the traffic to go out of the network. That is the essence of how stateful firewalls behave. Their rule sets are still comparatively limited in the same way that packet filtering firewalls are fairly limited. Stateful firewalls typically only look at, conceptually speaking, ports and protocols. They look at IP addresses, TCP, UDP ports, and things like that. They work particularly well with TCP, but they also work with UDP on top of that. One of their big disadvantages is that stateful firewalls as a concept don't examine any application layer related information. There is no deeper packet inspection that takes place. They simply go in and look at, source and destination IP, source and destination port and protocol, make a decision on that, create an entry in the state table, off it goes, and therefore the responding packets are allowed to come back in. Unsolicited inbound connection attempts are not allowed to come back in. Now, these things are everywhere. Okay, there's a really high degree of likelihood that the firewall that's at your house, that little box that's probably a D-Link or a Netgear or something like that, that you have, that thing is a stateful firewall. Certainly at your office, whatever firewalling solution you have, and in some way, shape, or form is going to incorporate stateful firewall concepts into it. So these things are pretty much ubiquitous in terms of their prevalence in people's networks. Because security for networking is a constant battle of cat and mouse, we see that when they initially came out, this concept of stateful firewalls, it was difficult to be able to go in and get traffic, past the firewall. Unless it was allowed out, it couldn't come back in. And certainly unsolicited connections weren't allowed in. But attackers are smart. And so what attackers realize is that in order to be able to get into the internal network, they need state. Okay. What I mean by that is they need a dynamic rule created on the firewall that's going to allow their traffic to come in. And the way that they're going to do that, one of the more common ways that they would do that, is to simply trick in some way, shape, or form the internal user to send data out through the firewall. And when they do that, that creates the state entry in the firewall that then allows the corresponding traffic to come back in. So imagine that an attacker could get, say, a piece of malicious code installed onto a computer on the internal network. So if we go backwards here, you have a piece of malicious code that's on, say, the Windows 7 box that's over on the left-hand side in this diagram. If that Windows 7 box is infected, it can be configured to send packets through the firewall to the attacker. That creates state in the firewall, which will then allow the attacker's packets to come back through. And they can be configured to do it on a regular basis so that what a lot of times people refer to as the state bubble would be maintained. The state bubble simply means that we are creating a persistent state that allows the attacker's traffic to be able to come back inbound into your internal network from the internet. So even though stateful firewalls are definitely a huge step forward compared to packet filtering routers, they're still not infallible because attackers have figured out ways to go in and circumvent them. And again, one of the things that allows for this maliciousness to occur is the fact that stateful firewalls, as a concept, don't do any deeper packet inspection. They don't drill down into anything that's application layer or application layer related to go in and see that if something is more nefarious is going on. They simply look at ports and protocols, typically at layer 3 and at layer 4. IP address, source destination, TCP headers, UDP headers, etc. Now, one of the other benefits that's mentioned right here is that you really only need an access control list in one direction. If you look back to when we were talking about packet filtering firewalls, first generation stuff, we saw that in order to really get things to be even marginally close to being secure, we needed to create rules that control the traffic that's allowed out, and then we also manually created rules that control the traffic to come back in. Now, with stateful firewalls, you don't have to do that. With the stateful firewall, and because everything is denied inbound by default, you don't need to create another rule there. Okay, nothing's allowed in. What you then do is you go create rules that define what's allowed out. And by defining what is allowed out, the dynamic inbound rules are created by the stateful firewall that allows the traffic to come back in. So it actually, in many respects, simplifies your configuration efforts to not have to think about the bidirectional nature of the traffic because the stateful nature of the firewall handles all that for you. One other important aspect of this, and again, this can be variable depending upon how your particular vendor's firewall solution has been implemented. But in general, stateful firewalls still allow for the client and the server to communicate with one another directly. Now, I'm going to go back and use this diagram to illustrate what I'm talking about. If the Windows 7 computer wants to talk to the web server, okay, they have to pass through that firewall that's sitting in the middle. So this device right here is our firewall in this network. When the traffic comes from the Windows 7 computer going to the web server, a state entry is created in the firewall's state table that's going to allow the web server's traffic based upon TCP source and destination port, IP address source and destination port, as well as the flag bits on the connection to allow that traffic to come back in. Okay, so that traffic is allowed out. But if you were to look at the actual traffic that's flowing back and forth, you would see a TCP send request sent from the Windows 7 computer, and that TCP send request would be received from the web server. When the web server responds, the web server is going to respond in the TCP header with a SYN ACK as part of the TCP three-way handshake. That SYN ACK is going to be received by the Windows 7 computer. What I mean is that the firewall in the middle, the stateful firewall in the middle, is allowing the communication, but is not, by definition, manipulating the communication. And the important distinguishing things here is that it's not doing any sort of address translation. Okay, that's not part of a stateful firewall, even though it might be integrated into your vendor's product. It's not part of what a stateful firewall is. There's no address translation. And the Windows 7 computer is still talking to the web server, as opposed to, as we'll see in a second with circuit level gateways, as opposed to the Windows 7 computer talking to the firewall and then the firewall talking to the web server. The firewall that sits in the middle is really just more of a part of the conduit between the two. But the client and the server are still talking directly to each other. The firewall is just allowing the communication to take place because you allowed it out and dynamic rules were created to allow it back in. Sweet. So that is, in essence, what second generation firewalls are, is stateful firewalls. Now, some of the reading that you may do on the internet may cause you to get confused because some of the stuff that you read about stateful firewalls and circuit level gateways may seem to either contradict or overlap or be otherwise confusing. But stateful firewalls as a concept today, that's them. All right. Circuit level gateways, which I've seen books that say the circuit level gateways are really second generation firewalls, but more often than not these days you're going to see stateful firewalls being listed as second generation firewalls. Circuit level gateways, if I had to pick one, is probably the closest to a thing that does not exist as a standalone entity in anybody's implementation. This concept of what circuit level gateways do has, through the evolution of firewall technology, sort of now become something that's more integrated in with other concepts of firewalling. So what I want to do right here is I want to talk about what a circuit level gateway is conceptually, what it does. Please don't necessarily try and jam this into a specific example in your office environment, even though I'm going to show you an example of a very simple example of how a circuit level gateway can go in and work. Now, one of the single biggest things with circuit level gateways is or circuit level firewalls, if you want to call them that too, is they hide the internal node from the external server. There is actually no direct connection between the client and the server, which is why I took the time when we were talking about stateful firewalls to go in and illustrate that a Windows 7 computer talking to the web server, if it's a stateful firewall, they're actually talking to each other. Okay, they're actually negotiating connection parameters and communicating directly with one another. If this was a circuit level gateway, what would actually happen is the Windows 7 computer would actually establish a connection to the circuit level firewall, the circuit level gateway. And then the circuit level gateway would establish a connection to the server. The benefit of this is it gives an opportunity for the circuit level gateway to go in and apply some firewalling concepts. Is the destination a legitimate destination? Is it one that the user is allowed to go to? Does it resolve in DNS? Things like that may be questions that a circuit level gateway goes in and evaluates. And if it is, then it will continue to proceed and establish the connection. This means that the client and the server never actually talk to each other directly. They are, in essence, having somebody act as a go-between, which kind of leads into the world of proxying. Okay? Even though circuit level gateways are not technically proxies, proxying comes as a more advanced concept that comes a little bit further on. Okay? But it is somewhat limited in that it's generally limited to TCP traffic. Now, that is not universally true, so please don't hate on me, but for the most part, it's very TCP oriented, although there are things that can be done with different solutions to send UDP and stuff through it. Okay. Big limitation is really the same limitation that we see with packet filtering routers as well as with stateful firewalls. Circuit level gateways do not inspect any upper layer traffic. They simply look at whether or not the parameters of the connection are valid from an IP addressing perspective and whether they make sense from a TCP header perspective. And if those things are all true, then it allows the connection to take place and no further examination is done. So they're still lacking from a more advanced security perspective to go in and control what can or cannot be done from a higher level protocol perspective. So let me go in and show you a simple example of this. Now, this is not a super true specific implementation. I just want you to understand conceptually what is going on. Now, to reiterate, a stateful firewall is going to allow the client and the server to actually communicate with each other. A circuit level gateway does not do that. A circuit level gateway has the client establish a connection to the gateway, and then the gateway establishes the connection to the server. We can actually do this with a Linux computer just running SSH. Okay? And it can actually be done with a single command. This command right here that you see actually allows me to go in and turn my Linux computer into a circuit level gateway, or really a SOCKS 5 proxy, to go in and actually establish these connections. So let me show you what I mean. Okay, in this example, what I want to do is I want to illustrate to you a few things to show you exactly conceptually how a circuit level gateway will work. All right, so what I want to do in this demo is I want to show you first what it looks like when a client just straight connects to a web server, which again, I suspect that a lot of you already know, but it'll help to make sure that we have the good compare and contrast between the way that something's going to work at, say, a circuit level versus the way that something would work in just a straight, routing traffic kind of perspective, whether there's a firewall in between or not. So if this client 44, 44, 44, 44 accesses this web server, Okay, so let's do a couple things. One, let's watch the connection from the web server's perspective. Okay, so there's currently no connections. It's trying to do some DNS stuff, but we don't care about that. There's no connection to the web server right now. All right, so that's on the web server, which is this kid over here on the right. All right, so on the client, let's open a web browser and point it at that web server. The web server is at 100.100.100.100. Okay. So when we do that, we see the web page comes up, and if we look at the active connection on both sides, both the client and the web server, we can see that on the client, he went from himself, he chose an ephemeral port of 39.124, and he went to port 80, and we see the same connection on the other side. The local port is port 80, and it's coming from 39.124. The thing that I want you to notice here is that the client and server are talking directly to each other. All right. If we were to capture these packets in Wireshark or something like that, we would see that there through a handshake took place and all the data is passing back and forth between them. Just normally routed traffic, nothing particularly special or interesting going on. Okay. Now what I want to do, just for the sake of this example, is I'm going to take this server out here, who's just running SSH. It's a Linux, Ubuntu box running SSH, nothing particularly fancy about it. And I'm actually going to configure it to be a SOCKS proxy, okay? And the simple command to do that is this one right here, okay? Now, if this were an actual circuit level gateway, of course, it would be, a firewall that sat in between these two networks. I'm using it as just another server in the network, but positioning is important to make sure that traffic has to go through your circuit level gateway, but technically, the circuit level gateway could kind of be anywhere. You could pass your traffic through it by just pointing your clients to wherever that circuit level gateway is going to be. I've started this SSH process in the background. So now you'll notice that if we look at this on my SSH server, I actually have a listener on port 1080. Okay. Now, don't run out and do that. There's more to securing this. Okay, there's no actual firewalling that's taking place in here. What I'm just doing is configuring this device just to actually be a proxy. Now, just to make sure, this device's IP address is 100.100.100.6. Okay, the web server's IP address is 100.100.100.100. Okay, and this is the server that we're going to want to connect to. The client's IP address, we come back and look at the client, is 44.44.44.44. Okay, so I'm going to go into the properties of my web browser here, okay, and I'm going to change the settings in my browser to have it point to my SSH server, which is acting as the proxy, as the gateway. Okay. So I'm going to change that value here. This is in Firefox. We'll do a manual proxy, and the SSH server, remember, had an IP address of 100.100.100.6. So that's who I'm going to configure to be my SOCKS 5 gateway, and the port that he's listening on is port 1080. Okay. Now, I'm going to say OK to that. I'm actually going to close my browser and I'm going to reopen it. Now, what I want you to see when we do this is the connection that's going to show up at the web server is no longer going to be like it was before, where the client connected directly to the server. Now the client's going to establish a connection to the SSH server, and the SSH server is going to establish a connection to the web server. So if we look at what we have right now as far as connections, on the client there are none. On the web server, there's nothing of importance to us. And on the SSH server, there are also, there's one connection where this guy's listening on port 22 for himself. Okay. So now I'm going to open my web browser. Okay, so let's look at each one of these connections and see what's going on. So this is from the client that we've just opened this web browser. Get that out of the way. And notice that even though the web browser is at 100.100.100.100, our connection doesn't go there. Our connection, because it's now configured to use the gateway, is actually coming from our local computer using an ephemeral port, going to port 1080 on the actual gateway, which is our SSH server acting as the gateway here, which is 100.100.100.6. If we actually go to the SSH server, who's acting as our gateway, we'll see that there's a connection from 44.44.44.44 on the 41606 ports, okay, 41606 coming here, connecting to his port 1080. And then the SSH server actually has a second connection. This connection is from a different ephemeral port locally, 100.100.100.6, in this case 56,582, which is ephemeral, going to the actual web server on port 80. And if we go look at the web server, we can see that the connection to the web server on port 80 is actually coming from the actual SSH server who's acting as our gateway. What this is illustrating to you, if we look at our network diagram, is that the connections coming from the client to the server, to our circuit level gateway here, or acting as a circuit level gateway, and then a second connection is being established to the web server. What this means is that the client never talks to the web server. The client only talks to the SSH server, and the SSH server talks to the web server. However, there is absolutely no inspection of the traffic going on by the device that's acting as our circuit level gateway here. If I wanted this to be more secure, I would actually go in and, one, I wouldn't just use this simple of a rule to go in and do it, but I'd also work in some firewall rules and things like that, so say using IP tables to go in and button this up a bit. But what this illustrates to you is the concept of how a circuit level gateway is going to go in and behave by going in and having it, having the clients establish a connection with the gateway, and then the gateway establishes the connection with the actual end server out there on its own. Okay. Now again, this really leads into discussions more associated with, in modern times, with anonymity on the internet and things like that, because you'll notice that the web server doesn't see that it's you that's browsing with the website. They only see the SSH server, and so you could have one of these set up, say at your house or at your office, and then no matter where you go, you could always point to that device, and then all the traffic appears to be coming from that device. Or you could set up your own virtual host on the internet with Amazon or Linode or any other device that's out there, and go and do this that way yourself as well. So that's all topics for a completely different discussion related to what we're talking about now, but it's kind of leads that way in terms of discussions. So that's circuit level gateways. So we've got stateful firewalls discussed, we've got circuit level gateways discussed, and did a brief demo on exactly what one of those is going to be. Keeping in mind that this can be done for really any protocol as long as the software knows how to do it. And the most common software that knows how to do circuit level stuff is web browsers, but it can be done with some other things. But I'll leave that for a discussion on another day. The last level of firewall that we see as far as firewall generations is third generation firewalls, which is application level gateways. Application level gateways can, in many respects, do everything that a stateful firewall can do in modern times, but they have the one distinguishing difference that makes them sort of, I don't always want to say better, but different than the others, in that they can actually go in and drill down into the application layer related information. They can look at HTTP, they can look at FTP, and they can even, in modern times, drill deeper down into the actual content and look for, are you downloading files, or are you browsing a web page, or is there malicious payload involved in this HTTP encapsulated data? Application level gateways are very frequently implemented as proxies, and so you might have a proxy firewall, and you get circuit level kind of behavior where you have the client configured to use the proxy firewall, and all of their particularly web related traffic is sent to the proxy firewall, the application level gateway, which is able to then go in and make some decisions about, one, is the user authenticated? Two, is the user allowed to be doing this based on the ports and protocols they're trying to go in and access, or the web pages they're trying to go to? And so more involved decisions can be made as to whether or not the traffic's going to be allowed to flow, which is a huge difference if you compare it to the way that circuit level gateways, stateful firewalls, or even packet filtering routers go in and behave. It comes with a pretty steep cost, though. The capacity to keep up can be tough. Okay, so it's perfectly plausible that an application level gateway can become a bottleneck in your network. Some people also have issue with it from a privacy perspective, because if you are establishing a connection to a secure website on the internet, let's say you're going to IT Dojo's website, which is a website that uses TLS for security. If you have an application level gateway that's in between you and the website you want to visit that's secure, you're actually going to establish a secure connection with the application level gateway. The application level gateway then establishes a secure connection with the website that you want to visit. And so the data is traversing its entire journey encrypted, but two separate negotiations for encryption. It creates the capacity for the application level gateway to inspect the data in its plain text form, which is by design. But that does cause some people to be concerned about the privacy implications of an abuse of privilege or something like that with the application level gateway itself, and that they're able to go in and actually see your data in plain text. Now, from a business perspective, tough. That's just, you work here, that comes with it. We inspect all the traffic that comes into and out of our network. That's the basic functionality of what they do. Now, in modern times, firewalls go to one other level that's beyond this, which is a multi-layer firewall. Multi-layer firewalls incorporate some or all of these concepts. They certainly have the capacity to go in and identify traffic based on the IP address that it's coming from or going to, or the ports and protocols that are in use. They're most certainly stateful, and they also have the capacity to act as proxies or even get into more advanced concepts like caching and things of that nature that they may go in and do. But they are multi-layer in that they have the ability to inspect your traffic from a firewalling perspective from not just layer 3 or layer 4, but also layer 7, and then deeper into the actual payload in layer 7. And at the enterprise level, that really is the modern state of firewalling. A lot of organizations just use stateful firewalls and go in and say, if it's coming to this port or protocol, then it's okay, and we'll just track the state on it. And that offers you a reasonable level of security, but if you're super serious about security, it's not an adequate level of security. And that's the reason why application level gateways or modern multi-layer firewalls that implement concepts, including application layer gateway stuff, are considered to be the most secure type of firewall, but it comes with a cost, and that cost is typically performance related. So that's the balance that you have to strike. And that's kind of really where I'll leave it with this. And just to quickly summarize, first generation firewalls are packet filters, second generation firewalls are stateful firewalls, third generation firewalls are application level gateways. Then you also have conceptual notions of firewalls like circuit level gateways and multi-layer inspection firewalls that we have in modern firewalling that we typically go in and do. So hopefully that you find all this information interesting and relevant, and it helps you to better understand everything, and you'll be able to tackle the exam questions that they ask you related to these topics. If you want to know more, if there's specific questions, maybe you saw a practice question or something like that was out there, and you want to know how that correlates to some of these things in firewalling, by all means ask me, and I will either answer you in the comments or I'll make another video that goes in and talks about it. But until that time, appreciate it. See you next time. Peace.